Hey guys, what to do? Today, I'm gonna do several problems in this review video to help just give you really more practice for your test on Friday. So, I have several problems here, and they're all slightly different so that you can practice different stoichiometry problems. The first one, I've written out the equation for you right here, okay? But notice it's not balanced. Anytime you see like a line, a little blank next to the compounds, you know it's not balanced. So we need to start off by balancing this compound. So on the left side of the equation, I see I have one carbon. We're going to start off by balancing carbons because we always balance oxygens and hydrogens last. Okay, so our carbons on the right side, we also only have one, so we're good. And now I'm going to balance my hydrogens because hydrogens are in a compound, but oxygens, there's, as you can see on the left, there's an oxygen that's by itself, and we always balance singles last. So on the left side, we have 4 hydrogens, and then we have 2 hydrogens on the right side. So I need 2 more, really. So if I put a big 2 here, that means is I've got now 4 hydrogens on the right side. So my hydrogens are now balanced. So now I can go and I can look at my oxygens. On the left, I see I have 2 here in this O2 compound. On the right, I have 2 in the CO2 compound, and then I also have 2 in the water compound. So I have a total of 4 oxygens on the right, but I only have 2 on the left. So if I put a big 2 here, I now have 4 oxygens total. Okay, so I'm going to just put big 1s here next to the blanks. So now I can actually solve my problem. It says I'm given 3.5 moles of oxygen, so I put that moles of O2 on top over 1, and it's asking for moles of something else. This is B, moles of B, and oxygen would be A. So it's asking for moles of CH4. It says how many moles of CH4 will react with 3.5 moles of oxygen. So I'm given 3.5 moles of oxygen, so that goes on the top over 1. I'm going to moles of CH4. So we've learned, guys, that we always start in, remember our pathway, right? It's like grams of A to moles of A to moles of B to grams of B. Well, we are not given grams of A here, right? We were given moles of A. So we're starting here in our pathway. We're really just skipping the part that has grams of A. So we're in moles of A. We put moles of A on the top over 1. And what comes after moles of A? Well, it's moles of B. So I'm going to put moles of B here. B being CH4. Okay. And then I would go to grams of B, except it's not asking for me to go there. It's just asking for moles of B. So I stop. I'm really just doing a mole-to-mole problem. So what goes on the bottom of this fraction? Well, we've always learned, remember, that the unit, not the number, just this unit right here, moles of O2, we've got to cancel out of it. We don't want to be in that unit anymore. And so we have to put moles of oxygen on the bottom so that these units really can cancel. Now that we do that, I can insert my numbers. When you have moles over moles, which we do here, see how there's a mole here and there's a mole here. So anytime mole and mole are in the same fraction, we're going to use these coefficient numbers to plug in. So I have 1 mole of CH4, so I put a 1. And in my equation, I have 2 moles of O2, so I put a 2 here. So now I'm going to solve. I'll do 3.5 times 1, which is 3.5. Shouldn't be a surprise. 1 times 2 is 2. But when I divide them, 3.5 divided by 2, which I probably should have done in my head, but don't judge me, is 1.75. And then what's my unit? My unit's always the last unit on the top because I've canceled out of everything else. So moles of CH4 is my answer. Okay, number 2. How many moles of H2O will be made from 2.1 grams of CH4? So I'm given grams of A, okay? So I'm given grams of A. That means I'm going to go to moles of A, and then moles of B, and then it just wants moles of B. That's all it wants. So I don't even need to go to grams of B. I don't have to do that part. So this one's just a 3-stepper. So I put my given over 1, 2.1 grams. This is A. CH4 is A now. So I put that over 1. So what's next? I've done grams of A. Okay, so what I do moles of A next. So moles goes on the top. And what's A? A is CH4, so I put that on the top. So 10 moles of A. Now what goes on the top of the third one is moles of B, which is H2O. Now I know that because it's asking for moles of water, moles of H2O, so that's my B. And now I've set up everything on the top. I just need to, remember, take my unit, not the number, just the unit, and I'm going to plug it down here so that I can cancel out of grams of methane. So what unit goes down here? Well, again, I'm going to take this guy and I'm going to put him catty corner so he cancels. So moles of CH4 are down here, so they can cancel. So now I just have to plug in my numbers. Here I have moles over grams. Anytime you see grams, you're going to put the molar mass. So I'm going to do 1 carbon plus 4 hydrogens, and I get about 16 grams. So I'll plug that in there. That's the molar mass of CH4. What number goes next to the mole, though? If it's a fraction where it's moles and grams or moles of anything else, like moles in atoms or moles in molecules or moles in grams, it's always 1. The only time we put numbers there other than 1 are when it's mole over another mole. When it's mole over another mole, that's when we use our coefficients. So if I look here, I see I have a coefficient of 2 for water, so I put that here, and then I have a coefficient of 1 for CH4, so I put that there. So now I'm going to solve, and I have an equation that's kind of in the way, so I'm just going to erase it. Okay, so 2.1 times 2 is going to be 4.2 divided by 16 gives me 0.2625. What's my unit? It's always the top one on the right because everything else is canceled out of. So moles of water is my answer there. Okay, so now we're going to move on to, I'm going to erase some of that, and we'll move on to our next problem. This problem requires us to write out our reaction. It's not really given to us. So let's write it out. It says we have potassium chloride will be synthesized. That means made. So I know potassium chloride is a product. Potassium's charge is +1 because it's in group 1. Chlorine's charge is -1 because it's in group 17. So those charges even out. So I just leave it as KCl. But what are the reactants? That's the product. What are the reactants? It says it's synthesized from, or it's produced from, potassium. Okay, so that's just K. And then chlorine gas, which is Cl. Now remember, when an element is by itself, it's always just 1, except if it's a diatomic, which chlorine happens to be a diatomic, so it's going to be Cl2. If you don't remember the diatomics, you may need to go back and rewatch one of our earlier videos. I'm trying to remember which one it was. 10.2 maybe? 10.1? Nope. I think it was Unit 9. I think it was sometime in Unit 9. Anyway, so now that I've written it, what do? Balance. You have to balance. And you have to sing balance when you balance. Otherwise, it's not balancing. That's a dumb joke. Anyway. Okay, we have 2 Cl's on this side. So I need 2 Cl's on my other side. So I put a big 2. Now I have 2 Cl's, but I also have 2 K's. So I put a 2 here. Now I have 2 K's on this side. I'm good to go. I'm Gucci. Okay. Now let me look at the problem. This problem is definitely different than the other ones we've seen because, was that the bell? Did the bell just ring? Okay, sorry, I'm back now. This problem is different because we're given 2 grams of, or we're given 2 reactants. It says 34 grams of potassium, okay? So since I have 34 grams of potassium, I'm just going to write it out right here. 34 grams. And I have 25 grams of chlorine, so I'm going to put that here. And I'm trying to find, it says grams of B, which is potassium chloride. So this is my B, okay? So the way we do this is you can always find your product by going from your limiting reactant and converting to your product, okay? Problem is we don't know whether potassium or chlorine is our limiting reactant. So I'm first going to take potassium, that'll be my A, and I'm going to go to potassium chloride. Then I'm going to take my other reactant, chlorine, this will be my other A, and I'll convert to the same product. Whichever one makes the smaller number is the amount of potassium chloride that can be made. It's also the limiting reactant. So Let's start with potassium. So I have 34 grams of potassium. Okay, potassium is my A, all right? And remember, we always go grams of A to moles of A. So I'm going to put moles of potassium on the top. Then we go from moles of A to moles of B. So B is potassium chloride. And then I go moles of B to grams of B. So grams of potassium chloride go there. And then I take my units. Remember, I always go catty corner. So unit on the top is also the unit on the bottom. So I'm going to do that for all of them. Moles of potassium go here. This is Cl, whoops. And then moles of potassium chloride go on the bottom. Okay, now I'm going to go ahead and plug in some numbers. So the first one I have moles over gram, and since, remember, the only time that we put real numbers next to moles is if it's moles over moles. But it's not moles over moles, it's moles over gram, so I always put a 1. This mole is also next to gram. It's not mole over mole, so I also put a 1 here. These two are grams, which means I have to do molar masses. The molar mass for potassium is 39.098, so we're just going to keep it at 39. Potassium chloride is going to be 39 plus chlorine's molar mass, which is 35.453. So that rounds up to 74.5 grams. Whoa! Whoa! I just put that in the wrong area. Let's take that guy out. Getting a little too excited about my numbers and I'm putting them in the wrong spots. Why is 74.5 going to go next? Go there. Well, it's going to go there because it's next to grams. And you always put the molar mass next to grams. Now, my last set of numbers are moles over moles, which means I get to use my coefficient. So, moles of K, I have 2 moles of K, so I put a 2 there. I have 2 moles of KCl, so I put a 2 here. And now I get to solve. So I'm going to do 34 times 2 times 74.5. I'm going to divide it, and then I'm going to put parentheses 39 times 2. So it looks kind of like this. I don't know if you can see it in the video, but anyway. And then I press enter, and my answer, I'm going to write, it's super crowded, so I'm going to write my answer right here. 64.9 grams of potassium chloride will be made when I use 34 grams of potassium, okay? So now I have to do that whole setup all over again with my other reactant, okay? So here's my other reactant. I have 25 grams of chlorine. And remember, chlorine is a diatomic, so I have to write Cl2 there. So chlorine's my A now. So I go from grams of A to moles of A. So moles of A goes on the top, and then I go to moles of B. What's my B? Well, I'm still going, remember, to potassium chloride right here. So KCl is my B. And then I go grams of B. And then I'm going to go catty corner. I'm going to put the units, same units that were on the top on the bottom, so I can cancel out. And then I'm going to plug in numbers. So this is moles over grams, so it's 1. This is moles under grams, so it's 1. These are moles over moles, so I get to use coefficients. So there's 2 is the coefficient of KCl, and 1 is the coefficient next to chlorine. So now I just have to do molar masses. So the molar mass of KCl we actually already calculated. It's right here, 74.5, so I just get to reuse that. Yay! But the molar mass next to chlorine I have to calculate, so it's 35.453. But how many chlorines do I have? I have 2. So you got to multiply it by dose, or 2 if you're not bilingual. And then you get 70.9 grams of chlorine. Now I'm going to plug and chug those numbers in my calculator. When I multiply the top, I get 3,725, and I'm going to divide in parentheses 70.9. Oh, it's just 70.9. There ain't nothing on the bottom to divide by. So my answer here is 52.5 grams of potassium chloride. So let's take a step back and think about that. Potassium right here will make 64.9 grams. Chlorine right here will make 52.5 grams. 52 is a smaller number. So this is how many grams of potassium chloride we can actually make. This other number is totally irrelevant to us. Chlorine is our limiting reactant because it makes the smaller amount. Okay, moving on to number, I don't know what number this is, but the next one. Let's move on to the next one. I'm going to erase some of this stuff so I have room to write. Okay.
How many moles of iron will you need? So that means iron's a reactant. With extra sulfur, okay, to form iron 2 sulfide. Okay, so we have to write out the formula for iron 2 sulfide. What does this 2 stand for? It stands for the charge of iron. So we have iron with a charge of 2. And sulfide is really sulfur. So I put an S there for sulfur. And sulfur, which happens to be in group 16, means its charge is -2. So those charges are evened out. Yay for us. We don't have to put any subscripts, which is so cool. It's also balanced because we have the same number of irons and sulfurs on both sides, which is great. Now let's look at the problem. So it says we have 20 grams of our product. So I'm going to write that here, 20 grams of iron sulfide over 1. And it's asking for moles of iron. So I'm going from grams of A to moles of A to moles of B, and then I get to stop. I don't have to go to grams of B. Why? Because it doesn't want grams, it wants moles. So I'm moving my units here, catty corner, right, so they can cancel out. What-de-do. Now I put in numbers. This guy is moles over grams, so it's 1. This guy's moles over moles, so I use my coefficients, which, by the way, they're all 1. So I'm just going to put a 1 there. And then I have grams. And so I do molar mass for grams. So molar mass for iron is 55.845. I'm going to add that to its buddy sulfur, which is 32.066. And I get 87.9. So now we just solve. 20 times 1 times 1 is still 20. And I just divide it by 87.9. And I get, I get a small number, 0.23 moles of iron. Ooh, yay. Okay, we got 2 more problemos to do, guys, and we'll be done. Okay, Bob has a percent yield of 78%. That means 78 over 100, right? That's 78%. Okay. How many grams of product did he actually make in the lab if he knew that he was supposed to make 34.5 grams of product? All right, this one we've never really done a problem quite like this, but if you're given a percentage, just make it into a fraction, okay? This is his percent yield, but I just made it a fraction instead of a percentage. And over here, I have my formula. Remember, it's actual divided by theoretical. So his actual, we don't know. That's what we're trying to find. How much did he actually make in the lab? That's what we're looking for. When he was supposed to make 34.5, that's my theoretical because it says he was supposed to make that much, okay? So really, I have x, which is the actual, divided by the theoretical, which is 34.5, equals my percent as a fraction. Guess what you can do here? You can just cross multiply and divide. So I'm going to do 34.5 times 78 divided by 100, or 100, and you get 26.91. So that's how many grams he actually made in the lab. Cool deal. Last problem. What's the percent yield? So I'm looking for the percent, which means it's actual divided by 100. Actual divided by theoretical times 100. It says his actual is 21.3, so let's put that on top. Its theoretical was 25.4, so I put that on the bottom. I'm going to divide these two, times them by 100, and I get 83.9% yield. And that's it. That's our review for the test. I hope I didn't go too fast. If I did, then turn it on slow mode. It might sound funny. And then this is Diamond making an appearance. Were you gonna shout out to something?
Yeah. Shout out to and everybody in 5th period.
Everybody in 5th period. Okay. All right. Goodbye and God bless.